Every few months, the headlines make the exact same promise. Astronomers have found it, another Earth 2.0, a lush, blue and green paradise waiting for us right next door in the cosmos. Over the last decade, a specific roster of exoplanets has dominated these announcements. You might recognize names like Proxima Centauri b, Ross 128b, GJ273b, and Wolf 1069b. They are our closest galactic neighbors, and on paper, they are incredibly promising. That promise comes from a specific mathematical grading curve used by the astronomical community. It is called the Earth Similarity Index, or ESI. This diagram shows exactly how the index works. It grades planets on a scale from 0 to 1, with Earth at exactly 1.0. To calculate a score, the index measures 4 parameters: radius, density, escape velocity, and surface temperature. When you plug our 4 neighboring VIPs into that formula, they all score between 0.85 and 0.86. According to the index, anything above 0.8 is categorized as an Earth-like, potentially habitable world. But the equation is missing a massive variable. It completely ignores the nature of the star those planets are orbiting. And all 4 of these planets orbit red dwarfs, specifically M-dwarf stars. By omitting that stellar context, the Earth Similarity Index acts a lot like a highly generous real estate brochure. It hypes up the square footage while completely obscuring the terrifying physical realities occurring on the ground. Let's start the cosmic audit right next door, at Proxima Centauri b. It is just 4.2 light-years away, and boasts an impressive 0.86 on the index. The problem is its host star. Proxima Centauri is an active M-dwarf, a highly volatile flare star, constantly erupting with intense magnetic storms. Because the planet sits so close to this violent star, it gets blasted with 10 to 60 times the amount of extreme ultraviolet and X-ray radiation that Earth receives from our sun. This animation illustrates the real physical threat. That radiation is accompanied by a stellar wind, a stream of charged particles crashing into the planet with a pressure 10,000 times stronger than our own solar wind. Under that mechanical force, any gaseous envelope collapses entirely. The atmosphere is violently stripped away, and any liquid water is instantly vaporized and lost to deep space. On Proxima b, getting a tan actually means being completely sterilized by stellar radiation. In active flare systems, an impressive Earth similarity score means absolutely nothing. You might point to a planet like Ross 128b, located 11 light-years away. Astronomers often pitch planets like this one as the safe alternative because its host star is considered a quiet, non-flaring red dwarf. Quiet red dwarfs carry their own fatal flaw. Because they are so cold and dim, a planet has to orbit incredibly close to the star just to stay warm enough for liquid water. This diagram demonstrates the physical consequence. The star's intense gravity acts as a brake, locking the planet's rotation to its orbit. For planets like GJ273b and Wolf 1069b, this creates a brutal binary. Despite scoring a 0.85, the star-facing hemisphere never experiences night, baking into a perpetually irradiated, bone-dry desert. Meanwhile, the dark side is plunged into endless night, completely frozen solid in the deep cold of the cosmic void. The only theoretically habitable real estate on these worlds is the Terminator line, a narrow ring of permanent twilight separating the two extremes, where the temperature might just barely allow liquid water to exist. So when the index calculates a temperate, comfortable average for these planets, it is a mathematical illusion. You can average a boiling oven and a deep freeze to get a comfortable room temperature, but you wouldn't want to live there. When astronomers label an exoplanet as Earth-like, they are communicating something very specific and highly technical. In astronomy, Earth-like merely indicates that a planet has enough mass to be a rocky body rather than a gas giant, but isn't so close to its star that its surface is actively melting into magma. It does not mean a lush, green world with breathable air. Yet we have poured billions of dollars, decades of research, and monumental engineering efforts into hunting for these mathematically defined Earth twins. Facilities like the Extremely Large Telescope are currently under construction in the Chilean desert specifically to peer closer at these very targets. Because M-dwarfs make up the vast majority of all stars in the universe, These irradiated, tidally locked nightmare scenarios are not rare exceptions. They are the galactic default. We project our own romantic desire for a second home onto data points that simply happen to match our radius and density. But the actual physical reality of our galactic neighborhood is unapologetically hostile to life as we know it. Earth is a freakish anomaly. We live in a cosmic neighborhood run by radioactive flares, where the habitable zone is just a mathematical technicality.